This is Mike O'Dell from the Penn, Ohio SCTE chapter. Extremely pleased to have Mr. John Downey, who's been a mentor and a teacher to me for, as we were just discussing, more than 20 years. So super excited to have John contribute to our channel. Now a consulting engineer, formerly of Cisco, but now with Technetics. John, thank you so much for taking some time to share with our viewers.
Oh yeah, no problem, and happy holidays.
Yeah, thank you. Same to you. We're in the little lull between Christmas and New Year's, so we figured it'd be a great time when meetings were at their lowest to get some content in the can for our channel. This is the first, John, and I know this is going to be a challenge for you and me to start recording a video series called 5 Minutes or Less. And the challenge that I threw out to you today was to talk about the evolution and the different versions of DOCSIS and what those differences mean. We've heard it bandied around for a long time, right? DOCSIS 1, DOCSIS 2, more recently DOCSIS 4. What does that even mean? So let's see if you can explain it to us. 5 minutes or less.
Yeah.
Go.
And thanks for having me. You know, those who don't know history are doomed to repeat it, right? So it's better just to know where we started and where we went or where we're going. If we start out with DOCSIS 1.0, this was a table from Cable Labs, and I thought it was a nice layout of the baseline of DOCSIS and data over cable service interface spec. So that's what it stands for. I don't know if you remember, it would start out with MSNC or something like that, like multi-service network something or other. There was actually another terminology at one time. It was MSNC or something. And then we came up with DOCSIS, and it was able to get everyone together to satisfy a standard and settle on a standard, and then drive prices down, which made it better for everybody in competition and made modems go from $300 down to $20 or whatever. So if you look at the very last column there, or row, when the date came out for the spec, 1996. So we're coming up on 30 years, right? So 2026 would be 30 years. So we're getting really close to 30 years with DOCSIS. It was it's sort of based on Ethernet and carrier sensing collision detection, and there was proprietary stuff out before this, LAN city modems. What else did we have? Motorola had something, Com21 had something. So there was some the Terion with SCDMA, and we settled on DOCSIS to use QAM, which is quadrature amplitude modulation. And we used 64 QAM or 256 QAM, so we had two different varieties. But it was always a 6 megahertz downstream channel for Annex B, which is US, 6 megahertz channels. But in Europe, they use Annex A of the spec, which is a 6 or 8 megahertz wide channel. So the channels are a little bit bigger in Europe, so that's what they came out with a different Annex or style of spec. But the modulation was the same, 64 QAM or 256 QAM. Upstream, we only had a couple options, right? We had QPSK and 16 QAM. So we knew upstream was always noisy, so we had to come up with a modulation scheme that was very robust. And QPSK is very robust. Quadrature phase shift keying, you're just shifting the phase by 90 degrees. Quadrature means 4. There's 360 degrees in an entire circle, so 1/4 of 360 is 90. If I take a sine wave and manipulate it every 90 degrees, I'm basically making quadrature phase shift keying. If I take that phase and shift it and then also manipulate the amplitude, that's QAM, quadrature amplitude modulation. You're doing the phase shifting and you're doing amplitude modulation to take an analog signal to represent digital data. That's what we do, right? That's how we optimize our cable plant and run digital, quote unquote, digital signals. They're really RF analog signals to represent digital data. And that's what a modem is, a modulator, demodulator. So you can see some of the specs there about the speeds that were listed, and it's rounded up, down. It's not really, that might be raw rate. Raw rate is everything. Usable rates, you got overhead for MPEG-2 encapsulation for downstream. You got sync messages. You got overhead for upstream maps, the timing for the upstream traffic that you have to put on the downstream. So there's some overhead there that will definitely drop the 40 down to like 37.5. The 10 megabits on the upstream is more like 8.89, somewhere around there. And then with DOCSIS 1.1, when I think about the terminology of the spec, When we went from 1.0 to 1.1, it was a software upgrade. We were able to add quality of service and voice traffic and things of that nature. And the spec didn't change anything with the physical layer. It just changed with quality of service and what we call UGS, unsolicited grant flows and things of that nature for software. When we get into hardware, now you're like, oh, I got to buy a new modem. I got to do new hardware in CMTS. That's where we changed the spec from 1 to 2. So we went to 2.0. 2.0 is really about getting higher upstream speeds by adding a bigger channel width. So we went from a 1.6 typical upstream channel width to a 3.2 to a 6.4. So we have a 6.4 upstream channel. We added 64 quality upstream, which made it faster. So our upstream went from 10 meg to 30 meg. Really usable is about 27. And then we went from 2.0 to DOCSIS 3.0, another hardware change. We're changing from 2.0 to 3.0. And that's where we got into bonding, where we took that same DOCSIS 2.0 physical layer stuff, but then we needed multiple channels and bond them together. And when we went to DOCSIS 3.1, now that's interesting because to me, 3.1, and our timer's done. When we went to 3.1, in my mind, it should have been 4.0 because we went to new hardware. We went to OFDMA, which is different multiplexing technique. We're not just bonding 6 megahertz channels together. We're taking subcarriers and we're doing something called orthogonal frequency division multiplexing. So OFDMA on the upstream, totally different hardware needed. In my mind, it should have been called DOCSIS 4.0. But hey, I think the DOCSIS 3.1 moniker was given for marketing purposes and make sure people realized, hey, 3.0 is not a waste. Don't bypass 3.0 and wait for 4.0 or 3.1. But it was, I don't know if it's a game we played or what it was, but to me, it's a lot of hardware changes when we went to 3.1. Now we get DOCSIS 4.0, which we're talking about now. It's definitely hardware-ish changes. Really the same modulation schemes. It's just doing more of it and adding. What else do we have with DOCSIS 4.0? The ESD extended spectrum DOCSIS, so the frequency space was hardware. More channel capacity that the modems can handle, that's hardware. And then security things of that nature. And what else on the upstream? I would think FDX, right? FDX is a big one. Full duplex DOCSIS where you could have upstream and downstream frequencies at the same instant in time in the network, not at the modem, but in the network could be FDX.
Yeah, that one's going to take a little while to get our heads around. But the other thing in the transition between DOCSIS 3.0 and 3.1, you mentioned hardware. I think the band splits that were supported in 3.1 were different too. Is it where was high split introduced? Was that 3.1 or was that 3.0?
So in US, we were always at 42 on the upstream. Euro DOCSIS was 65. We did we called it a mid split, and that was 85 megahertz in DOCSIS 3.0. So that's DOCSIS 3.0 spec. DOCSIS 3.1 took that all the way up to 204 megahertz on the upstream.
Right.
So, and then on the downstream, it was always 999 or 1 gigahertz, or the band edge of your 6 megahertz last channel was really 1.002, right? But the center frequency was 999 of the last 6 megahertz channel that you could do in a 3.0 spec. 3.1 extended that to 1.2 gig. And so if you were doing single carrier QAM, you could go all the way up to 999. But if you're doing 3.1 at OFDMA, you could go anywhere you want. But that last 1 gig to 1.2 basically would be an OFDM channel or block, 192 megahertz block.
So
4.0, totally different, right? 4.0 extended spectrum DOCSIS ESD could go to 1.8 to like 1.794 or something like that. 1.8 gigahertz for the downstream, and upstream, that's where people had the differences of opinion. Whether I do a 396 upstream or an FDX where I can go an upstream and downstream overlapping each other. Yeah, so up to 684, right?
Yeah, so the interesting thing is, in kind of summary, as the needs of the consumer evolved, and it was really around, data rates. How much data could we fit in the pipe and supply the needs of the customer base? As things kind of migrated from, linear video based through switch digital video and pay-per-view and all that stuff, where so much of the video consumption now is really just data. from over-the-top streaming video services and even the operators themselves offering IP video. So as the spec evolved, it was really to support that, right?
Agreed.
And to
And then it turned out the Wi-Fi had to catch up.
Yeah.
We kept adding more capacity. And it's like, well, most people don't do wires in the house anymore. They want to do Wi-Fi. So we went from, Wi-Fi 6 to now they're talking about Wi-Fi 7 as well.
I think that's another 5 minutes. We'll have to do another 5 minutes on Wi-Fi. But yeah, so a little more than 5 minutes. But thanks for walking us through, John, to from where we started, at least in terms of the DOCSIS specification back in the mid '90s, all the way through, us where we're really cracking the surface today of DOCSIS 4. So I'm sure there's going to be a lot more to come. But thanks for running us through sort of that DOCSIS evolution in this episode of 5 minutes ish or less.